let's talk about the eye as a lens. So the eye as a lens obeys the same thin lens equation we talked about before. Um, if and what it does, and actually in the language of optometrists, 1 over the focal length is called the power of the lens. All right, P. So your optometrist will talk about your power of your glasses, power of your lens. So when an object is very far away, the muscles of your eye in your eye try and flatten the lens out to make it a longer focal length so the object that's very far away gets focused on your retina. And then when objects are nearby, they try and squeeze in the lens to make it fatter in the middle. And by doing that, they give you a shorter focal length, and so you can look at objects that are closer up. So it's just a thin lens. We call the power the 1 over the frequency. In a normal healthy eye, the distance between the lens and the retina is 2 centimeters. And so when you get in, if you ever if you ever become an optometrist, ophthalmologist, you'll get accustomed to the language around that and the, the some of the math that works out here, but because DI is always the same. Um, so how does this go wrong? So if you're nearsighted, you have myopia, that means your lens is too strong or your eye is too long, right? So the lens too strong means it can't flatten enough for you to see far away, or your eye is too long, it just can't focus on things that are far away. If you have hyperopia, which is farsightedness, right, then it could be that the lens is too weak or the eye is too short. Right? And when the lens is too weak, the focal point, I mean, where you're trying to focus the image is back behind the eye, or if the eye is too short, where you're trying to focus the image is back behind the eye. When nearsightedness, where you're focusing the image is too close, it's not back on the retina, or if the eye is too long, you're focusing the image too close, it's not back on the retina. Um, when you start creeping up past age 40, most people begin to experience some degree of hyperopia. So basically, you can no longer spread your lens out far enough um, uh, when you need to, right? And so in farsightedness, you just can't make your lens do what you need for it to do to see the objects that are actually the other way around. You can't get your lens to squeeze down enough, pardon me, got that backwards, to squeeze down enough to see objects that are up close. You have no problem the other way, but they just won't squeeze, the lens won't get thick enough or strong enough to see things that are up close. So, and that's age related. Almost everybody begins to experience that in their 40s. And the way you'll know this is happening to you is your arms get too short for you to read. You can no longer hold what you're trying to read far enough away to read it. Okay. Um, so here, myopia, the lens power is too large, and so what we put in front of the eye is a lens with negative power or negative focal length. So you put a diverging lens in front of the eye, and you get you correct some of the overpower of the lens in myopia. And hyperopia, you put a converging lens out in front of the eye to give it a little bit more power and to increase the power overall. Now, glasses are not, well, contacts and laser vision correction in some ways are superior to glasses in that glasses, my glasses are not fixed with respect to where my eye is, but your contacts and laser vision correction are. Right? I've actually had laser vision correction in my 30s because my lens was way too weak, and I had to have a -6 and a -6.5 diopters on my left and right eye, respectively. And I got to where I saw 2015 for a very long time, and now I have to have some vision correction, both for age-related hyperopia and and just a little bit more farsighted, nearsightedness, and some astigmatism. Right? And astigmatism is simply your lens has one focal length in one plane, and another focal length and another. So your lens is no longer symmetric, and now it's kind of oval shaped rather than being a circle. It becomes more of an oval and doesn't focus the same way along the two different axes of the oval. All right, that's it for the eye as a lens, and we'll start talking about color vision in the next slide.